Alright, so for our next example, we are looking at that power of 0. Now, one of the things I want you to realize when you're working with the power of 0 is you have to be very specific about what is being raised to the 0 power. So in this particular problem, the x here is being raised to the 0 power. So this is the number 1. But this 3 stays. So what we're basically doing is instead of having 3 times x to the 0, we have 3 times 1. The same thing is true here with our y. Y to the 0 is what's being raised to the, or y is what's being raised to the 0 power. So this is going to be a 1. But the 2 is going to stay just the way it is. So this will be 2 times 1. So then we have, well, 3 times 1 is 3. 2 times 1 is 2, so we have 3 minus 2, and we do happen to get out an answer of 1. That was just a coincidence. Sometimes it'll be different, but just understand the difference between raising the whole thing, which would mean that was in parentheses, or just raising the x to the 0 power. That 0 only goes to the x because that's the only thing it's associated with. Had we written it as 3x in parentheses to the 0 power, then this would have been 1 because the 0 goes to both the 3 and to the x. It's responsible for the whole thing becoming 0, or 1, excuse me. Okay, so for question number 7, we're looking at multiplying two terms together. So our first term is negative 6ab squared, and our second term is 5a to the negative 2 b to the negative 3. Well, the first thing I want you to realize when you're doing this is all multiplication. So you're multiplying these three terms together, you're multiplying these three together, and then you're multiplying them together as that. And one of the great things about multiplication, just like addition, it's commutative, which means that we can multiply in any order that we want. We don't have to keep it like it was given. So one of the things I want you to do is just rearrange so that your numbers and your letters are beside each other. So for instance, negative 6 times 5. Those are both the same, so I'm going to put them next to each other. And then we have a times a to the negative 2. And if you need to, remember that we talked about our rule. If it doesn't have an exponent, it's automatically a 1, so we can do a to the first. And then we have b squared times b to the negative 3. So now we just need to use our rules of exponents and our multiplication to combine these together. First, starting off with our multiplication here, that's going to give us negative 30. When we take these guys right here, we're going to add them together. Again, being really careful of your signs. When we do 1 plus a negative 2, you're basically saying 1 minus 2, which is going to give us a to the negative 1. Same thing here with our b's. We're going to add our b's together since we're multiplying them. So b squared and b cubed would be also b to the negative 1. But remember, as part of our instructions, we want all of our exponents to be positive, and right now both our a and our b have negative exponents. So both of these terms, because they are both telling us they are not in the right place, need to be moved to the denominator. The 30, just because he's negative, does not mean he needs to be moved. His exponent here is a positive 1, and it's the exponent that tells you to move it, not the number itself. So this would be negative 30 over a b. And notice that when I moved them to the denominator, I didn't write the power of 1 on either one of those because when there's not a number written there, it's automatically assumed to be a 1. So I don't want to write a to the first and b to the first. If I do that in my homework, it'll tell me my answer is not simplified because it doesn't like 1s in the exponents, just like it doesn't like having a 1 in front of the variable. Okay, so for our next example, we're looking at negative 24 x to the third over negative 4 x squared. And what we're going to do is very similar to what we did on the previous one. We're actually going to break this up and we're going to look at two different divisions. We're going to look at negative 24 divided by negative 4, and we're going to look at that times x to the third divided by x squared. Okay, so we look at our division of our numbers first, and we're saying, okay, well, negative 24 divided by negative 4 is going to give us a positive 6. And then again, remember our rules of exponents. If we're dividing our variables, we're going to subtract our exponents. So 3 minus 2 would give us x to the first power. Again, we wouldn't want to write to the first power. We would just say our answer is 6x. So for our last example, we're looking at simplifying negative 5x to the negative 4y squared. And really the only thing we have to simplify here is the fact that this guy right here, x to the negative 4, he's in the wrong spot. He's not happy in the top of the fraction. He wants to be moved to the bottom. So all we're going to do is take 5 and y squared, because they're perfectly fine in the top of our fraction, and place that over x to the 4th. And that would be our answer. Remember, negative exponents aren't anything to be scared of. They just mean they're in the wrong spot. So if it's in the top of a fraction and has a negative exponent, it just really wants to be moved to the bottom. Anything that's has a positive exponent just stays in the top of our fraction. And vice versa is true. If it has a negative in the bottom of our fraction and we want to move it to the top, we can do that anytime we see that. And if it has a positive exponent, it just stays where it is.